You're standing on the deck of a U.S. Navy aircraft carrier in the middle of the ocean. The wind is roaring, jet engines are screaming, and suddenly, an aircraft launches off the deck with no pilot inside. No cockpit, no human hands on the controls. Yet it flies perfectly, lands precisely, and even refuels itself mid-air. That's not science fiction, that's happening right now. And it's changing everything you thought you knew about naval aviation. If you think drones are just small quadcopters or surveillance tools, you're about to see how wrong that idea is. Because today, you're stepping into the future of warfare, where autonomous aircraft operate alongside human pilots, extending reach, increasing survivability, and redefining power at sea. Before we go deeper, tell me this in the comments. Would you trust a fully autonomous aircraft to operate from a carrier in the middle of the ocean? You're about to explore one of the most advanced technological evolutions in military aviation. From the groundbreaking X-47B to the game-changing MQ-25 Stingray and the massive floating cities that launch them, this is the story of how the U.S. Navy is building the future of unmanned combat in the sky. And once you see how it all connects, you'll never look at aircraft carriers the same way again. Let's start with something that shocked even experts when it first happened. An aircraft lined up on a carrier deck, no pilot inside, no joystick control in real time, just code, sensors, and algorithms. Then, in a moment that made history, it launched using a catapult system just like a traditional fighter jet. That aircraft was the X-47B. You're looking at a machine designed not just to fly, but to think, adapt, and operate in one of the most dangerous and complex environments on Earth, an aircraft carrier deck. The X-47B wasn't just another drone. It was a proof of concept that changed the entire direction of naval aviation. Developed by Northrop Grumman, this unmanned combat air system was designed to test whether autonomous aircraft could safely integrate with manned operations. And the results were beyond expectations. Imagine this. You're landing on a carrier at sea. The runway is moving, the space is tight, the margin for error is almost zero. Now imagine doing that without a human pilot. That's exactly what the X-47B achieved. It performed autonomous carrier landings using arresting wires, aligning itself with precision that rivaled experienced human pilots. It wasn't just following a simple path. It was adjusting in real time based on conditions, speed, and deck movement. That level of precision opened doors no one could ignore. If that impresses you, hit subscribe now because what comes next is even more advanced. Now think about endurance. One of the biggest limitations of manned aircraft is human fatigue. Pilots can only stay in the air for so long, but unmanned systems don't have that problem. The X-47B took things further by successfully performing autonomous aerial refueling. That means it could extend its mission time significantly without needing to land. Picture this: a drone flying hundreds of miles from a carrier, linking up with a tanker aircraft, connecting to a refueling system, and continuing its mission, all without human hands controlling every move. That's not just impressive, that's transformational. And this is where you start to see the real shift. Instead of replacing human pilots, these systems are designed to work with them. You now have a future where manned and unmanned aircraft operate as a team. The drone can go further, stay longer, and take greater risks, while human pilots focus on decision-making and mission control. Let me ask you something. Do you think future wars will rely more on humans or machines? Drop your opinion below. Now, while the X-47B proved what's possible, the Navy realized something critical. The biggest immediate need wasn't a stealth strike drone. It was range. Modern fighter jets like the F/A-18 and even the F-35C are incredibly powerful, but their range limits how far a carrier can project power without support. And that's where the MQ-25 Stingray comes in. This aircraft might not look as futuristic as the X-47B, but don't underestimate it. It's one of the most strategically important drones ever developed for carrier operations. The MQ-25 is designed as an aerial refueling drone. Its mission is simple but critical: extend the reach of other aircraft.
Think about that for a second. Instead of sending a manned tanker aircraft into potentially dangerous airspace, you send a drone. It flies out, carries thousands of pounds of fuel, and refuels fighter jets mid-air, allowing them to go farther and stay longer. That means carriers can operate at safer distances while still projecting power deep into contested regions. That's a huge advantage. The MQ-25 can deliver around 15,000 pounds of fuel to aircraft operating hundreds of miles away from the carrier. That one capability alone changes how missions are planned. Now fighter jets don't need to carry as much fuel themselves. They can carry more weapons or sensors instead. It's like turning every aircraft into a more capable version of itself. And here's the interesting part. This shift didn't happen overnight. Originally, the Navy wanted a stealth strike drone program. But over time, priorities changed. The focus moved toward practical capabilities that could be deployed sooner. That's why the MQ-25 exists today as a refueling platform first. But make no mistake, this is just the beginning. What you're seeing is the foundation for future unmanned systems that will likely take on multiple roles, including strike missions. If you're still watching, you're clearly interested in this future. So here's something to think about. Would you feel safer knowing drones are taking on the most dangerous roles instead of human pilots? Now let's zoom out for a moment, because none of this works without the aircraft carrier itself. These ships are more than just floating runways. They are some of the most complex machines ever built. Take the Nimitz-class carriers, for example. These massive vessels operate as mobile air bases, capable of launching and recovering dozens of aircraft in rapid succession. But what's really fascinating is what happens below the deck. You don't see it in most videos, but there's an entire world underneath. Multiple levels, storage areas, maintenance zones, and systems that keep everything running. Aircraft are stored in hangar bays, moved using specialized equipment, and lifted to the flight deck using massive elevators. Every movement is carefully coordinated. Now imagine adding unmanned aircraft into that environment. It introduces new challenges. How do you manage autonomous systems in tight spaces? How do you ensure safety when machines are making decisions? The Navy is actively solving these problems. New technologies, updated procedures, and dedicated units are being developed to test and refine these operations. And that brings us to something many people don't talk about: the testing units. Before any of these systems become fully operational, they go through extensive evaluation. Specialized squadrons are tasked with testing unmanned aircraft, pushing their limits, and identifying potential issues. These units operate a wide range of drones, from small surveillance systems to larger platforms like the MQ-8 Fire Scout. The Fire Scout is another example of how unmanned systems are expanding capabilities. Unlike fixed-wing drones, this one is a helicopter. That means it can take off and land vertically, operate from smaller ships, and perform missions that require hovering. It's used for surveillance, reconnaissance, and target tracking. With advanced sensors, it can monitor areas for extended periods, providing real-time information to operators. And because it's unmanned, it can be deployed in situations that would be too risky for a human pilot. Think about how valuable that is in a conflict scenario. Now you have eyes in the sky that can stay longer, go further, and operate without putting lives at immediate risk. Let me know, do you think drones like this will eventually replace traditional helicopters? Now let's go back to the carrier deck for a moment, because this is where everything comes together. Launching and recovering aircraft is already one of the most demanding operations in the military. Add unmanned systems into the mix, and it becomes even more complex. But it also becomes more efficient. Autonomous systems can follow precise patterns, reduce human error, and operate with consistency. They don't get tired. They don't lose focus. And when integrated properly, they can actually make operations smoother. That's why newer carriers, like the Ford class, are being designed with the future in mind. They include advanced systems like electromagnetic catapults and improved elevators. These upgrades aren't just about performance. They're about preparing for the next generation of aircraft, including drones. The Navy isn't just adapting to change, it's building for it. And this is where things get really interesting, because what you're seeing today is just the early stage. In the future, you could see swarms of unmanned aircraft operating together, sharing data, coordinating missions, and supporting manned fighters. You could see drones acting as decoys, electronic warfare platforms, or even frontline strike assets. The possibilities are massive, and they're closer than you think. So here's a question for you. If you were in charge of designing the next generation of naval aviation, would you focus more on unmanned systems or keep humans at the center? Drop your thoughts below. As you step back and look at the bigger picture, one thing becomes clear. This isn't just about new aircraft, it's about a shift in how wars are fought. Unmanned systems are changing the balance. They extend reach, they reduce risk, they increase flexibility, and when combined with advanced carriers and skilled operators, they create a powerful force. But it also raises important questions. How much autonomy is too much? Where do you draw the line between human control and machine decision-making? These are questions that engineers, military leaders, and policymakers are still working through, and the answers will shape the future. You're witnessing a turning point. Just like the introduction of jet engines or stealth technology, unmanned systems are redefining what's possible, and the pace of change is only accelerating. So if you've made it this far, you already understand something most people don't. The future of naval aviation isn't just coming, it's already here, and it's evolving faster than anyone expected. Make sure you're subscribed, because the next video is going even deeper into the technologies shaping modern naval warfare, and you won't want to miss it. Until then, keep your eyes on the horizon.